Hi, this is our continuation of our topic on limits. So our next expression will be limit of u squared minus 4 over u minus 2 as u approaches 2. Now if you recall the difference of two squares, looking at u squared minus 4, this is actually a difference of two squares. So what is the expression for difference of two squares? Now if you recall, a squared minus b squared is equal to a plus b multiplied by the other binomial a minus b. So in this case, u squared minus 4 is actually equal to u squared minus 2 squared. Now, here you can see here u squared minus 2 squared is actually equal to a squared minus b squared. So u will be a and 2 will be b. So in this case, expression a plus b, a minus b will now be equal to u plus 2 multiplied by u minus 2. So that's a refresher on the difference of two squares which we learned in our algebra. Therefore, I can now express this expression as the limit of u plus 2 multiplied by u minus 2 over u minus 2 as u approaches 2. Take note, if I substitute u by 2 in the denominator, if I substitute u here by 2, you get 2 minus 2 equal to 0. Now if I substitute u is equal to 2 here, it will be 2 minus 2 equal to 0. So 0 multiplied by this expression will be 0. So what you get 0 over 0, which is indeterminate. So obviously you cannot substitute u is equal to 2. So what you can do here, but take note as well, you can now cancel u minus 2 in the numerator by the u minus 2 in the denominator. You can now cancel both terms here, and now you're left with the limit of u plus 2 as u approaches 2. This is now equal to substituting u by 2. You get 2 plus 2 is equal to 4. So our final answer will be 4. Another example will be the limit of 2x squared minus x minus 10 as x approaches 3. Take note that this is a linear expression. So you can also see here that in this you can see here that it is not a fraction. It is a trinomial, not a linear expression. It is a trinomial, but it's not a fraction. There is no denominator here other than 1. So what we can do here, we can substitute x is equal to 3. So let's see what happens. So this is equal to 2 multiplied by 3 squared minus 3 minus 10. So here, in this trinomial, we substitute x is equal to 3. We substitute x by 3, and you can get this, which is now 2 multiplied by 9 minus 3 minus 10. This is now equal to 18 minus 3, and minus 13 will give you negative 13. So now 18 minus 13, this will give you 5. So as you can see here, this trinomial, this is defined at x is equal to 3. So it's not a problem, you can easily substitute it. So the answer here will therefore be 5. Now, we now go to another problem. Limit of 3y squared minus y minus 10 over y squared minus 4. So you have a trinomial here divided by difference of two squares. So if you can easily factor this out, no problem. But if you're having problems factoring this, then we have an easy solution how to do this. So how do you factor the numerator 3y squared minus y minus 10? So what we can do here, so let's write 3y squared minus y minus 10. First thing we need to do is multiply the leading coefficient of 3 with the constant negative 10. So 3 multiplied by negative 10 will give you negative 30. Now, look at this coefficient of y. Coefficient of y is negative 1. So let me put negative 1 here. So what we need to do is we need to find two factors such that if you multiply them, you get negative 30. And when you add them, you get negative 1. Let me repeat. I need to get two factors where if you multiply them, you get negative 30. And if you add them, you get negative 1. Negative 30 comes from the product of the leading coefficient 3 multiplied the constant negative 10, while negative 1 is the constant of this variable y. So negative 30, let's say, let's put 1 and negative 30. If you multiply them, you'll get negative 30, but when you add them, you get, so if I add 1 plus negative 30, you will get negative 29. Obviously, this is not what we want. So just to be clear, let me just put multiplication sign there. Now another, let's try 5 and negative 6, for example. So 5 and negative 6, 5 multiplied by negative 6, you will get, let me put again multiplication sign there. 5 and negative 6, you will get negative 30, so that's fine. But if you add them, let's see what happens. 5 plus negative 6 will give you negative 1. So that means these are the two factors that we need, 5 and negative 6. Because if I multiply 5 and negative 6, I get negative 30. And if I add 5 and negative 6, I get negative 1. Now, we can now express this numerator into the following. Let me just put a line here. Now 3y squared minus y minus 10 can be expressed in a different way using these two factors. So this will be 3y squared, okay? Now using these two factors here, negative 6y, and using this factor here, plus 5y, and then reusing this, minus 10. Take note here. Negative 6y plus 5y is still equal to negative y. So you're not changing the expression. It's the same thing as this. You're not changing the expression. You just re-express negative y into negative 6y plus 5y. So next, what do is we factor out the greatest common factor for these two terms here and the greatest common factor with these two terms here. So what's the greatest common factor for these first two terms? Of 3y squared minus 6y. So greatest common factor will be 3y. So 3y squared divided by 3y, then you will get y. While negative 6y divided by 3y, you get negative 2. Let's just check. 3y multiplied by y, you get 3y squared. 3y multiplied by negative 2, you will get negative 6y. Plus, the greatest common factor of these two terms here, 5y minus 10, will be 5. So 5y divided by 5, you'll get y. And then negative 10 divided by 5, you'll get negative 2. We now find the greatest common factor for this whole expression here. And as you can see, the greatest common factor will be y minus 2. So 3y multiplied by y minus 2 divided by y minus 2, you'll get here 3y. And then 5 multiplied by y minus 2 divided by y minus 2, you will get 5. Therefore, this expression 3y squared minus y minus 10, which is also our numerator in our original expression, is equivalent to y minus 2, quantity y minus 2 multiplied by 3y plus 5. So now, our expression now is now equal to the limit of y minus 2 multiplied by 3y plus 5. So we have re-expressed this 3y squared minus y minus 10 into y minus 2 multiplied by 3y plus 5. And don't forget to put y approaches 2. Now, look at this y squared minus 4. This is a difference of 2 squares. This is also equal to y squared minus 2 squared. So y squared minus 4 is equal to y squared minus 2 squared, which we can express now as, if you recall, the difference of 2 squares, a squared minus b squared, is equal to the product of the binomial a plus b multiplied by a minus b. So therefore, I can now express this difference of 2 squares into y plus 2 multiplied by y minus 2. You can see here, I have y minus 2 in the numerator and y minus 2 in the denominator. You just cancel them both, and now you're left with this. So let me put some space. Now, we now have the limit of 3y plus 5 divided by y plus 2 as y approaches 2. I can now substitute y with 2, and I will get 3 multiplied by 2 plus 5 divided by 2 plus 2. This is now equal to 3 times 2, 6, plus 5, we get 11. 2 plus 2 is equal to 4. So our final answer will be 11 over 4. So that's what we all have for today, and more examples in the next video.